All right, so today we're diving deep into the mind of Immanuel Kant.
One of the most influential thinkers in history.
Absolutely. And specifically, we're exploring his philosophy of science.
His philosophy of science, yeah, fascinating stuff.
Oh, it can be challenging for sure.
Definitely, but really rewarding to dig into.
Kant was an 18th century philosopher who really wrestled with this question of how we can have scientific knowledge if our minds, shape how we experience that world.
Yeah, a question that's still relevant today, especially when you think about like physics.
I've always found it so interesting how Kant's views on physics kind of evolved over time.
Totally, like he was on this intellectual journey.
It's like he was refining his ideas as he went.
Right, as he grappled with new concepts and challenges, yeah.
So we're talking about his pre-critical period, the critical period,
And even post-critical period.
each with their own unique perspective on physics.
These acts.
It shows his commitment to rigorous intellectual exploration.
Especially early on, in his pre-critical phase, he was really interested in cosmological problems.
Yeah, like building a metaphysical foundation for his theories of matter.
Exactly.
One of the things that really struck me from this period was his work on the vis viva controversy.
Oh yeah, that debate about measuring force.
Everyone was weighing in on that.
From Leibniz to Descartes.
You can already see Kant trying to find a way to bridge those seemingly opposing viewpoints, even in these early writings.
Absolutely. And what's so fascinating is that instead of just siding with one camp or the other, he's trying to find a synthesis.
Yeah,
He suggested that both MV and MV4, the two big contenders for measuring force,
right.
could be conserved, but depending on the context.
Interesting.
It really points to a theme in Kant's approach, seeking that reconciliation between those seemingly incompatible perspectives.
Yeah, he's like, hold on, what if there's a bigger picture here?
Right, exactly.
What if we're all missing something? And to get to this bigger picture,
He digs into the metaphysical underpinnings of those concepts
like he's linking force to this activity of substances.
and using that to explain everything from the motion of bodies to even the mind-body problem.
Exactly, and this focus on substance and activity becomes even more, pronounced
Oh, yeah.
in his later work, like in his physical monadology,
Where he tries to reconcile the infinite divisibility of space.
a concept from geometry.
Right, with this idea of simple, indivisible substances.
That's a key concept in metaphysics.
Totally.
Okay, that sounds like a real head scratcher.
It is, it is.
How can something be infinitely divisible and indivisible?
Well, Kant's solution is ingenious.
Laid on me.
He argues that these simple substances, they fill space,
Okay.
but not just by existing through their spheres of activity.
Spheres of activity. Okay.
Almost like each substance has this like bubble of influence,
I like that bubble of influence.
And it's these bubbles that interact and create the spatial properties that we observe.
Oh, okay.
So that avoids the problem of having to chop up the substances themselves.
That's brilliant.
Right.
Sidestepping that impossible dilemma.
Totally.
But as I kept reading, it became clear that Kant didn't stop there.
Of course not.
He kept refining these ideas, especially as he moved into his critical period,
Right.
marked by his,
Landmark work.
critique of pure reason
Where he really starts wrestling with the limits of human understanding.
and how those limits affect how we see science.
Precisely. And that shift is evident in his metaphysical foundations of natural science.
That's where he lays out this specific definition of what is scientific knowledge.
Very demanding.
He sets a really high bar.
He does.
He argues that true scientific knowledge, first of all, must be systematically ordered,
Okay.
based on rational principles,
Uh-huh.
and known a priori.
With absolute certainty.
That's a tall order
Huge order.
for any field.
Absolutely.
So he argues that true science, it requires what he calls a pure part.
This foundation rooted in metaphysics to provide that level of certainty.
Yeah. And he makes this bold claim.
Yeah. He says, in any special doctrine of nature, there can be only as much proper science as there is mathematics therein,
Wow.
emphasizing that role of mathematics.
You can see why that statement sparks debate,
Oh, huge debate.
because it shows how much he believed in the connection between the structure of our minds and the structure of the world.
Absolutely. And it's important to distinguish between what Kant calls the transcendental and special metaphysical parts of science.
Okay, break that down for me.
The transcendental part that deals with the laws that govern the concept of nature in general,
Okay.
which he addressed in the Critique of Pure Reason.
Oh.
But the metaphysical foundations focuses on the special metaphysical part,
All right.
the part that deals with specific types of objects, like matter.
So he's saying, okay, we have this general framework for understanding nature from the critique. But now let's apply it to the stuff we encounter in the world.
Exactly.
And to do that, we need to be able to construct these concepts in a way that allows for a priori knowledge.
That's the key. That's the crux of it. And for Kant, this construction process starts with an analysis of the concept of matter itself.
Like, what is it? How do we experience it?
Exactly. And he argues that this concept of matter needs to be defined
Okay.
and explored according to the categories that he laid out in the Critique of Pure Reason:
And those are...
quantity, quality, relation, and modality.
So he's taking these fundamental categories of human understanding and applying them to our experience of matter.
Trying to create this comprehensive and scientifically sound picture.
And this approach leads him to some pretty controversial conclusions.
It does.
He argued that certain fields,
Like chemistry,
and psychology, as they were practiced in his time,
couldn't be considered proper sciences because they lacked that essential pure part, that grounding in a priori knowledge.
it's a bold statement.
It is.
It's fascinating to see how he grapples with the boundaries of what we call science
Yeah,
and how his philosophical framework shapes those boundaries.
it does. And all of this sets the stage for a deep dive into those 4 chapters of the metaphysical foundations.
Each tackling a different aspect of matter and how we experience it.
Yeah, it's going to be good.
I'm ready. Let's jump in.
Let's do it.
Let's start with the first chapter, Pheronomy, and see how Kant applies his ideas to the concept of motion.
So in the Pheronomy, Kant really focuses on the quantity of motion in matter,
Okay?
specifically how we can represent this concept in a way that aligns with his idea of a priori knowledge.
And he gets super specific here, right?
Super specific.
He narrows his focus to matter, considered as a single point in space,
Yeah.
to explore how different motions can be combined, like he's trying to break it all down.
Like into the fundamental building blocks.
Exactly.
Yeah.
And it's interesting how he tackles the concept of relative motion here.
Yeah, it is.
So he argues that because space itself is relative, we have to think about combining motions in a particular way.
A very particular way.
So it's not as simple as just like adding velocities together.
That-
There's more complexity here.
Because of how we perceive motion.
Exactly.
Yeah.
So to really grasp the nature of motion, we need to imagine one motion happening in absolute space.
While the other is represented as the movement of relative space in the opposite direction.
Okay, I'm gonna need a little more help wrapping my head around that.
Sure.
Can you give me like a concrete example?
Okay, so imagine 2 boats, right?
Oh, okay.
Traveling on a river.
Okay.
One boat is moving with the current, the other is moving against it.
Right,
From someone standing on the riverbank, both boats are in motion.
right.
But from the perspective of someone on one of the boats, the other boat's motion will appear different depending on whether they're traveling the same direction or the opposite direction.
Ah, okay.
So Kant is saying that to understand motion truly, we have to account for both the motion of the object and the motion of that frame of reference.
That makes more sense. So how does he use this idea to build his theory?
Well, he examines 3 possible scenarios: motions in the same direction, motions in opposite directions, and motions at an angle to each other.
Okay.
And in each of these cases, he shows how we can construct a single unified motion out of the 2 initial motions.
It sounds like he's laying the groundwork for like the fundamental principles of classical physics, like how we add velocities together using vectors.
Oh, that's a great insight he is. By working through these scenarios
Yeah.
and outlining the rules for how motions can be combined, he derives
A priori?
a priori concepts like the parallelogram rule for velocity addition
Oh.
and the Galilean transformations.
So he deduced these principles through pure reason.
Through pure reason, exactly.
That highlights the power of Kant's approach.
For sure.
So in the second chapter, the dynamics Kant shifts his focus to how we experience matter as filling space.
And this is where things get really interesting, diving into the world of forces.
I have to admit, this is a chapter I found the most challenging,
Yeah,
but also the most rewarding.
it is. It is.
Yeah. You know, we're talking about forces like attraction and repulsion, concepts that physicists today still grapple with.
Oh, absolutely.
But Kant is approaching them from this philosophical perspective.
Exactly. He argues that to understand how matter fills space, we can't just describe its physical properties. We have to think about the forces that govern its behavior.
So forces are not just something we observe, they're fundamental to the nature of matter itself.
Fundamental, exactly.
And he starts with the repulsive forces, right?
He does.
Making this bold claim that repulsive force is essential for matter to fill space.
Absolutely essential.
What's the reasoning?
Well, he takes issue with the idea that matter fills space just by existing.
Okay.
An idea he attributes to other thinkers of his time.
Yeah.
He says, if matter just passively existed in space, there would be nothing to prevent it from collapsing. We need a force, something to push matter apart to give it extension.
So each bit of matter is saying, back off, this is my space.
Yeah, exactly. Get out of here.
I like that.
And Kant goes on to outline some pretty important characteristics of these repulsive forces.
Okay.
He says they can have varying strengths. One can be stronger or weaker than another.
Okay.
And he asserts that while matter can be infinitely compressed, it can never be fully penetrated.
Because full penetration would mean overcoming an infinite force.
Which is impossible.
Right. Okay, so we have these repulsive forces pushing matter apart, but then something must be holding it together.
Right.
Otherwise, everything would just fly apart, so enter the attractive forces.
Exactly. Kant presents what he calls a balancing argument, demonstrating the necessity of both attractive and repulsive forces working together. Without attractive forces, matter would just scatter endlessly into space.
Okay.
But without repulsive forces, it would collapse into a single point.
A cosmic dance.
It is a cosmic dance, a delicate balance.
It's like a cosmic tug-of-war.
It is, holding everything in equilibrium.
And Kant doesn't shy away from the tricky metaphysical implications of these forces.
No, he doesn't.
He argues that attractive forces, like gravity, act at a distance through empty space.
Right, through empty space.
And this was a really contentious issue.
It challenged that idea that any interaction requires direct contact.
It sounds like he's anticipating the debates that would go on for centuries in physics.
Oh, yeah, absolutely, about the nature of those fundamental forces.
Like gravity and electromagnetism.
Exactly.
Wow.
He was ahead of his time.
In so many ways.
Yeah.
One thing I found really fascinating in this chapter
What's that?
is how he contrasts what he calls the mathematical-mechanical mode of explanation with the metaphysical dynamical mode.
All right, break it down.
Okay, so what's the difference?
The mathematical mechanical mode, which he associates with thinkers like Newton, focuses on explaining the world in terms of the shapes, sizes, and motions of fundamental particles, a very concrete, quantifiable approach.
Okay.
The metaphysical dynamical mode emphasizes the role of fundamental forces like attraction and repulsion in shaping the behavior of matter.
So the first one is like describing what things are doing, and the second is explaining why they are doing it.
That's it.
Like one describes the motions of the planets, the other explains why they move the way they do because of gravity.
You got it. And Kant acknowledges the value of the mathematical mechanical approach.
Yeah.
But he favors the metaphysical dynamical one.
For him, it offers a deeper understanding.
Deeper, more complete. Yeah, getting at the underlying causes of motion and interaction.
Okay, so we've explored the nature of motion and the forces that govern matter.
We have.
I'm really eager to see how he builds on this foundation in the next chapter, mechanics.
Well, in the mechanics, we see Kant grappling with the question of how motion is communicated between objects.
Okay.
And he lays out his own laws of motion, both similar to and distinct from Newton's famous laws.
Right, and before diving into those laws, he tackles this challenge of how we measure the quantity of matter.
And he proposes.
He says that the only reliable way to do this is by measuring the quantity of motion at a given speed.
That's right.
It's interesting how he rejects other methods.
Like counting the number of parts in matter or relying on volume.
Right, because matter is infinitely divisible.
Infinitely divisible.
So counting its parts is impossible.
Yeah.
And volume can be misleading because different types of matter can have different densities.
Exactly.
But measuring the quantity of motion offers a more consistent way to quantify matter.
A more fundamental way.
It's amazing how the ideas from the previous chapters are woven together to support the arguments in this one.
I know, it's like this really systematically built philosophy of science.
Each piece fitting into the larger puzzle.
It is. It is.
So let's get to those laws of motion.
Okay, let's do it.
So his first law states that the total quantity of matter remains constant even through changes.
It does.
And he connects this to the principle of the permanence of substance, something he explored in the Critique of Pure Reason.
Yeah.
His second law argues that any change in matter must have an external cause.
Which sounds a lot like...
Like Newton's law of inertia.
Yes, but with nuances. He links this to the idea that matter is lifeless, meaning it doesn't have any internal drive to change its motion. Exactly. It needs that external force to act upon it.
Right, and he rejects the concept of inertial force.
Which was a common idea at the time.
He thought it was misleading.
Yeah, confusing inertia with reaction.
Okay, and his third law tackles this concept of reaction,
Head on.
stating that for every action,
Equal and opposite reaction.
there's that connection again.
To the idea that all actions in the world are interactions.
Yeah.
One object can't affect another without being affected in return.
It's fascinating to see how he weaves these ideas together, drawing on his metaphysics, epistemology, and physics.
Creating this picture of how motion works.
This deep dive into Kant's mechanics has been incredibly illuminating.
It has.
So what about that final chapter, phenomenology?
Well, in the phenomenology, Kant shifts gears a bit
Okay.
and dives into the modal aspects of motion.
The modal aspect.
How we experience motion in terms of possibility, actuality, and necessity.
Okay, I'm going to need some help unpacking that.
All right, so think of it like this.
Okay.
We can imagine an object moving in a certain way, even if it's not actually doing so.
Okay.
That's the possibility of motion. Then there's the actual experience of seeing an object in motion.
Okay.
That's actuality.
Got it.
And finally, there's this concept of necessary motion,
Okay.
where the movement of an object is determined by laws or conditions, like gravity causing something to fall.
So he's categorizing our experience of motion, adding another layer of analysis.
Exactly.
How we understand the world.
Exactly.
Okay.
And he lays out specific propositions for each of those categories.
Okay.
He argues that rectilinear motion, motion in a straight line, is merely possible. Circular motion, however, is an actual predicate of matter. It's a real property that matter can possess.
Okay.
And finally, he proposes that the equal and opposite motion of one object in relation to another is a necessary motion.
Arising from that law of action and reaction?
Exactly. So he's making a connection between the type of motion and its modal status.
Or how certain we can be about its existence.
Exactly.
Right.
And all of this leads to a discussion of a concept that has been central to debates about physics for centuries. Absolute space.
Absolute space. That idea of a fixed and immovable background.
Against which all motion is measured.
I was wondering when that would come up.
Right. So Kant, having laid out his theory of relative motion earlier,
Yeah.
grapples with how absolute space fits in. He concludes that while we can't directly experience absolute space, it functions as a regulative principle in scientific thinking.
Okay.
It guides our search for a more complete understanding of motion.
Even if we can never fully grasp it?
Even if we can never fully grasp it.
It's like a theoretical horizon that we're always striving for,
Yes.
but can never reach.
Exactly.
It highlights how he recognizes those limits of human understanding.
Even as he pushes the boundaries of what we can know about the world.
So this exploration of the phenomenology has really driven home how Kant's philosophy of science isn't just about physics or mathematics.
It's not.
It's about the nature of knowledge itself,
Right.
about how our minds shape our understanding of the universe.
Exactly.
You know, as we've been going through Kant's metaphysical foundations, one thing that's really stood out to me is his emphasis on the concept of laws. Like, they seem absolutely central to scientific knowledge for him.
Oh, absolutely. Laws for Kant represent that very essence of scientific understanding. You know, they're the principles that allow us to move beyond just like observing the world to actually like comprehending it, you know, seeing order and regularity amidst what might seem like chaos.
But he's not talking about just any laws, right? He's got this very specific idea of what makes a law scientific.
Right, exactly. Like for Kant, a scientific law isn't just a description of regularity we see. It's got to be a judgment or proposition that is both necessary and imposed by a faculty of the mind. So it's something we can know with certainty a priori based on how our understanding is structured.
So for a law to be truly scientific, it can't just be something we observe. It has to come from how our minds understand the world.
You got it. And this is where Kant's idea of gnomic import comes in.
Gnomic import, okay.
It's this idea that laws don't just describe the world, they determine the objects that they govern.
Okay, that's a pretty wild idea.
It is.
Can you give me an example?
Okay, so imagine a law like the law of gravity, right? For Kant, it's not just that objects happen to behave according to gravity. It's that our very concept of an object, like how we understand what it is shaped by the law of gravity. It's like the law is woven into the fabric of reality.
Wow, that's a powerful way to think about it. No wonder he put so much emphasis on laws.
Right.
And this is clear in his focus on those 3 specific laws of physics we talked about. conservation of mass, the law of inertia, and the equality of action and reaction.
He considered those the fundamental laws of mechanics.
Yeah, the bedrock of our understanding of motion and interaction.
Exactly. And he really works hard to justify them, drawing not just on his analysis of matter and force from the metaphysical foundations, but also on those deeper transcendental arguments from the critique of pure reason.
It's remarkable how he brings all of these different threads together. It's this incredible system where metaphysics, epistemology, and physics are all connected. He's not just doing physics, he's building a whole worldview.
That's exactly what makes Kant so fascinating and influential.
Oh.
So he's not just interested in the specifics of science, he's asking these huge questions about the nature of knowledge, reality, and how we as humans fit into it all.
And, all Kant is really strict about what counts as proper science, with that emphasis on a priori knowledge and mathematical principles. He doesn't just limit himself to physics and math. He's also interested in fields like chemistry and biology.
That's right. He knows there are other ways of understanding the world, even if they don't have the same level of certainty as physics. Like, take chemistry. He says it's not a proper science in the same way because it relies on observation and experimentation.
Yeah.
But he still thinks it's a rational science because it tries to unify and explain different things in a systematic way.
So even though chemistry back then was still based on observation and experiment, he saw a kind of rationality in its search for general principles.
Exactly. And his views on biology are fascinating, too.
Yeah, how do we reconcile our understanding of mechanical laws with living things?
Right, with the purposefulness and complexity of organisms.
It's that classic tension, right, between a mechanistic worldview where everything is determined by laws and the idea that living things have this goal-directedness.
That's the core of it. And to deal with this, Kant comes up with the idea of natural purposes.
Natural purposes, okay.
He argues that organisms are unique because they're both cause and effect of themselves. They have this self-organization and goal-directedness that can't be fully explained by just mechanics.
So a tree, for example, isn't just a bunch of matter following physical laws.
Right.
It's also driven by some internal purpose, this striving to grow and reproduce.
Exactly, and this leads him to one of the most intriguing and debated parts of his philosophy of biology, the antinomy of teleological judgment.
Okay, the antinomy of teleological judgment. Break that down for me.
So he lays out these two seemingly contradictory ideas.
Okay.
First, we have to judge the creation of organisms as possible according to mechanical laws.
Right.
But second, some things in nature, like organisms, can't be judged as possible just by those laws.
So we have to assume organisms work within the framework of natural laws.
Yeah.
But their complexity and purpose seem to point to something more.
It's a real puzzle, and Kant's attempt to resolve it has caused a lot of discussion and interpretation.
Makes sense.
Ultimately, he says we need to appeal to a supersensible ground, something beyond our experience to fully grasp the nature of organisms.
So there's a limit to what science can tell us about life.
Yeah, a deeper mystery that we can only glimpse.
That's one of the most profound parts of Kant's philosophy.
It is.
It's all about science and reason. But he also knows there are mysteries that might always be beyond us. He shows us both the power and the limitations of understanding.
He does.
Well, this deep dive into Kant's philosophy of science has been a real mind-expanding journey.
It has.
From his early work in metaphysics to his theories of knowledge to his thoughts on different areas of science, Kant has given us an incredible framework for understanding how our minds and the world are connected.
What's amazing is how relevant his ideas still are today.
I know, right?
We're still wrestling with the same questions, like what are the limits of what we can know? How do we reconcile the fact that our experience is subjective with the objective reality of the universe? How do we make sense of the purpose we see in life in a world governed by physical laws?
So many big questions.
Kant might not have all the answers, but he gives us the tools to ask the right questions.
It's like he's given us this intellectual toolbox
Yeah.
to deal with the deepest questions about ourselves and the universe.
And that's maybe his biggest contribution.
Yeah.
He challenges us to think critically, to question what we believe, and to never stop exploring the mysteries of the world in our minds.
Absolutely. And so to our listener, we'll leave you with this final thought to ponder. If science is all about uncovering universal laws, but our minds shape how we experience things, can we ever really know those laws as they are in themselves? It's a question that still challenges and inspires philosophers and scientists today. Until our next deep dive, keep exploring, keep questioning, and keep that wonder alive.